Thank you so much. Hope you all had a great 15-minute break. In today's final session, we're going to examine AI's potential in education. How can AI address the shortage of teachers in the world or motivate students and increase their performance? Today's speakers will address some of this potential. To start the conversation, please allow me to introduce Dan Schwartz, the Dean of Stanford's Graduate School of Education and Faculty Director for Stanford's Transforming Learning Accelerator. Dan's research focuses on the intersection of cognitive science, computer science, and education, and how technology can facilitate learning. Dan, you can put on your slides and take it away.
Thank you, Ross. Thank you, everybody, for being here. It's my pleasure to kick us off. So the title here is a little spicier than what the talk's going to be. My point is really pretty simple, that new technologies often start by imitating old technologies. So early movies look like stage plays. MOOCs put classroom-style lectures online at scale. And right now, a lot of AI in education is naturally automating what currently exists. And what currently exists is largely based on intuition and historical accident. And so I'm concerned that AI may make us more efficient at what's basically not very effective instruction. Instead, I'd like to propose a human-centered approach that you start with the nature of learners. So the last 30 years has seen strong science on many forms of learning, and AI can augment better ways of teaching. And I think it can be a Trojan horse, a major force for changing how we go about teaching children, adults, and so forth. But to do that, it really needs to consult the science of learning. So I'm taking a slightly different approach today. I'm not actually going to talk about AI. I'm going to talk about learning. But hopefully it can give you a sense of the need for new possibilities and what some of those possibilities are. So what I'm going to talk about is contrasting cases. So this is something that you'll probably understand. If you want someone to be able to notice what makes a certain wine taste unique, special, that you taste it in the company of other wines. And so this is the basic idea of contrasting cases. And these are important because it's hard to tell what a thing is just by itself. So let me give a quick example. I'm going to show a picture on the right, and you're going to tell me what the thing on the left is. Well, you're not going to tell me. You're going to think it really loud, so maybe I can hear it. Okay. So given this, you probably say it's a circle. So let me give a different one. Now you might say it's a biggish circle. Now you'll notice it's an empty circle. And then I do it again, and you'll sort of notice, oh, it's got a black line. And so these contrasts are helping you notice what are the key features that you're supposed to pay attention to. I'll give you one more. It's on the left side of the screen. So this can go on forever, that any single instance has many, many different things. And contrasts help you figure them out. Turns out this is a very important aspect of how we learn, and it's something that's missing in almost all instruction. So take the case of learning polygons. It's probably been a while that since you've seen polygons, but here's what we would normally do. We would give students examples of polygons, right? And these are all positive examples. Here, I can give positive examples, which are still on the left, and then I can give examples of things that are not polygons. And we usually don't do that when we teach. We don't give negative examples. We tend to only give positive examples because we want people to be able to follow them. But if you haven't seen the negative ones, it's hard to know what's important about the positive ones. So we did a quick study on this where we asked people, what are the properties of polygon? And in case you've forgotten, like all of us, the three key properties are, it's a closed figure, it has straight lines, and the lines do not cross. And so what we did is we just asked the participants to list key properties of polygons before and after looking at the sheets. They either got to see the sheet with the positive examples or the sheet with positive and negative examples. So at pretest, before they looked at the sheets, our poor participants didn't really remember or know much about polygons. After they looked at the sheets, they did better. And what you need to notice is the ones who saw examples that were not polygons did twice as well as the people who saw the examples with polygons. So this is the power of contrasting cases, right? And it's simple, it's intuitive, it's not intuitive because it's not an instruction, but it is intuitive because you knew it in the case of wine. So I want to give you a more sustained example of what curriculum could look like if we followed the science of learning. And the example actually comes from a course I taught. It was a psychology course. And what I discovered was the students were doing very well on the tests I was giving. You know, they're all getting A's. So I'm feeling pretty good, you know, because my lectures must be special if they're all getting A's on my tests. But I had this realization that the goal was actually should be for them to analyze and predict human behavior, right? That's what psychology is. So I changed the instruction to align with this learning goal. And what I did is I had students analyze simplified data sets from classic studies. So these data sets are contrasting cases. And they had to graph the interesting patterns in the data. So I'm going to walk you through this in a little bit of detail, just so you get a sense of how it really works. And I'm going to mention two groups of people. Students are the people in my class that I did the study on. Participants are the faux data that the students analyzed. So they would get data from, my students would get data from participants, and then they would look at it and see what patterns they could find. And so here's an example of one of the worksheets. It says, graph the important patterns you see in the data. And then it would give some background information. The data come from an experiment in which research participants tried to remember a list of words. Participants listened to 1 word per second. They did not see the list, they only listened to it. Afterwards, the participants wrote down as many words as they could remember. Here are the list of words that the participants heard in the order. And then below, this is the data that my students received about the participants' memory. So your task over the next 15 to 20 seconds is to see what patterns you notice in the participant data. So it's kind of fun to look for patterns. We're good at it. Here, the one key thing is people remembered the last word in the list first at a very high rate. And then this one's a harder one to find, that they tended to remember the first word at a very high rate as well. So students would do this, they would graph it, and they would get a series of these. So they would get the next experiment, looked identical with this change that in this study, the participants counted down from 99 by sevens. So they would hear all the words, and then they would go 99, 92, 85, and so forth. The students in class would see the data now when you change the experiment, and they were, right? And here's what people remember when you've made this small change. So you can look at this and see what you notice. So to cut it short, now they're remembering the first words of the list at the front, and they're not remembering the word bag anymore. So this makes a nice contrast. Before they didn't count down, and in this study they did count down. We have a contrasting case that helps students notice the important differences. After the students would do these activities, I would give a lecture that described the experiments, the relevant patterns, and the theories that explain them, right? So for example, I would say primacy. This is when people remember the first things they hear, and they tend to remember them first. And recency, people remember the last things they hear first, but they forget if they're asked to try and remember after there's been a delay. And then I'd give an explanation. These are explained by the finite capacity of the working memory buffer and the odds a memory will be transferred to long-term memory and so forth. So I'm not trying to explain this all to you. I'm just trying to give you a sense for how it went. So I decided to conduct some studies. And there was an analyzed treatment. College students analyzed the data for homework, the way I described, and they made graphs of the important patterns. The summarized treatment was more typical of what we have students do. They read a chapter that summarized the results and the experiments and explained the theories. And they did this for homework, and their job was to write a 2-page summary of the chapter. So this is a very typical model of instruction. I give you a reading, I have you write a summary. They both took about the same amount of time. It's about an hour, right? Whether I had them analyze the data and look for patterns or had them read the chapter and summarize it. So I made 3 conditions in this experiment. In one, there were the students who summarized the chapter and wrote it, and then they heard a lecture. In the other, there were students who analyzed the data, and then they heard the same lecture because they were sitting in exactly the same class when I gave the lecture. And then finally, there were students who analyzed the data, and then they analyzed it again. So I said, please look for more patterns, see if you can find other ones. So all told, there were 3 conditions: summarize plus lecture, analyze plus lecture, and analyze plus analyze. So we continue. These studies are complicated. A couple days later, they got a memory test. It was a very standard kind of measure. I said, people tend to remember the first thing they hear better than other things. True, false. When people do not understand, they tend to remember verbatim. True or false. I haven't talked to you about verbatim versus just recall. But that was part of their exercise, right? So they got a bunch of these questions. And so here are how they did on that. So you can see the summarize plus lecture and the analyze plus lecture did pretty well. The analyze plus analyze group didn't do very well at all, right? Because it's a true false test, 50% would be what you would get if you were just guessing, right? So it looks from this like the lecture is the key thing. So a week later, the students took a second test. They had to predict the outcomes of a novel experiment. Right. So I just presented them with an experiment they had never seen before. And this was their prediction test. Their job was to understand what the experiment was and then predict the results. So they would see participants read the following passage. And here's an example of the passage. I'll let you read this for a few moments. And in one condition, the participants saw a title called Washing Clothes. So imagine it says washing clothes. And now I want you to take a few moments to reread the passage and it'll make a lot more sense. All right, so now you understand why red problems are the worst. The other half of the participants just saw the title passage 3. 5 minutes later, the participants wrote down what they read. So remember, you're a student in my class, you're hearing this description. Your job is to predict what the participants remembered in each condition. And so the question is, how well did the students do at that? They could make a total of 8 correct predictions based on what they had been taught. So participants will remember the first sentence better than others. Passage 3 condition will remember verbatim, while washing clothes condition will remember gist. And these are examples of things that participants said that were correct predictions. So your job is to predict how the students did. What is the percent of correct predictions by treatment? So what percentage of the 8 on average did the summarize and lecture students make? Predictions did they make? So I want you to think about this for a little bit. Maybe 60, 60, 40, 20, 20, 20. So let me show you the results because they're kind of surprising. And Most people make the wrong predictions. So it turns out by the very standard model of having students write a summary and then hear a lecture, they really didn't learn how to use their knowledge. They looked good by a verbal memory test, but when they had to try and use it, they were very poor. The analyze plus lecture did really well, right? This is a hard task. Nobody's going to get 100%. And analyze didn't look very good. So let me explain these quickly. Summarize lecture condition, what happened? Well, the students knew by the verbal recognition test where they had to say true, false, because the test matches the form of the lecture, which is true for most of our tests. They look very much like what we just told people. And that's fine, except that's not a form that you can use your knowledge to predict, right? Verbal statements don't solve the problem. And this is the problem of inert knowledge. Students knew the propositions and the facts, but they didn't use it. And this is the classic transfer problem. And one way to think of this is they have unconditionalized knowledge, right? They never learn to recognize the instances that should trigger their memory for what is relevant to that instance. A great example of this is a study of a clinical psychologist. They had just finished their degrees and they could tell everybody about all the theories, but they couldn't diagnose any patients because they'd never learned to see the cues that help them see the patients, to see the symptoms that tell you which theory is applicable. So you have to learn to see the cues in the environment. This is very hard. How can you come to see what you cannot see? You don't know where to look for it. You don't even know if you see it. This is where contrasting cases are very helpful. And that's exactly what the summary condition did not get. Next, we can look at the analyze condition. They were bad at the memory test. They never converted what they observed into general verbal propositions. So they never came up with sentences in their head like people tend to remember the first things they hear better than other things. And they were bad at making predictions, which makes a lot of sense because they'd only seen these phenomena in the context of word lists. So how could they know that they also apply to passages? That's why you need theory. Finally, the analyze plus lecture condition. They did well on the memory test. There was no magic here. It was a good lecture, and they were eager to learn the answers in the lecture since they had just engaged in the problem. They also did well on the prediction task. And the reason is the analysis led to the precise knowledge of the key phenomenon, and the lecturers generalized the precision with the why. So let me give an analogy. So the analysis task used experiments and data. So the experiments are contrasting cases by design. One study without a delay, one with a delay. Contrast produced differentiated knowledge, and that's the key to being able to apply it. So here's the analogy. Imagine I give you this pair of scissors and I ask you to describe it. What's important about it? Right? And you'll say things like, well, it's got finger holes and it's got a cutting blade. But let's say I put it in the context of a set of contrasts and I ask you to notice what's important about it, right? And you might notice it looks quite different than B, for example. And you look at all these different features like A is very good for cutting cloth because the flat end allows you to put it on the table. So once you've had a chance to see these features, the explanations are going to indicate why they're important. So for D, the thick blades, the big finger holes, and a fulcrum near the tip are all important to apply a strong force to toenails. So these are for toenail cutters. Once you've done this differentiated knowledge and you get an explanation, it really puts you in position to handle new situations. So if I showed you this new pair of scissors, you're much better able to think about what it must be used for, right? It has big handles, so you have to apply a lot of force. But I wonder why it has a sharp tip. And so this is what the analyze plus lecture condition did for the students. So it turns out summarize plus lecture, our standard method of instruction that we've inherited over the last hundreds of years, isn't very good for the kinds of outcomes we want. Namely, students can use their knowledge in new situations. So you may be looking at this and thinking, you missed a condition, Dan. And so that condition might be, well, what if you gave them the lecture first and then gave them the contrasting cases? Would that work? Because I really like having students learn lectures first, right? I want them to know before I tell them. So let me give an example that answers that question. So this, on the left, you have a very highly designed set of contrasting cases. And let me give you the cover story. There are 3 companies that ship clowns to events, and they always pack their clowns by the same amount. And so people need to know the crowdedness index for a company because crowded clowns are grumpy clowns. And the key here is this is a cover for density, and the contrasting cases are very important because a lot of 8th graders will say happy clowns is a 2 because they'll just focus on people, the number of clowns. But then they'll look down here and they'll say, oh, wait a minute, this is also 2, but they're different. And these contrasts get them into the game. Ultimately, what you want them to understand is it's a ratio. It's the number of clowns per compartment. And each little square in the bus is a compartment. So the bottom is 2 clowns per compartment. Bargain basement is 3 clowns per compartment. Happy clowns is 1 clown per compartment. Okay, so this contrasting cases sheet to help students discover density and ratio. The ratio is very important.
1 minute.
So we ran a study with 2 conditions, a tell and practice condition, which looked like almost all instruction in math and science. We told them about density. We told them about ratios. We had them do some problems, and then we gave them this sheet and said, please come up with the index. The other condition, we didn't tell them anything. We just gave them the sheet and said, come up with a crowdedness index. So in one case, we told them first, and then they got the contrasting cases. In the other case, we gave them the contrasting cases and said, see what you can figure out. 24 hours later, we asked them to redraw the sheet. If you look at this top one, this is a redrawing. This student never saw the ratio that's fundamental to density. So they've got 7 clowns in 2 compartments and 1 clown in 2 compartments, right? So this student never saw ratio or density. Interestingly, this student did correctly compute the density because they had been told first. Here's a student whose redrawing reveals the structure of density, right? It's 3 clowns per compartment. So we looked at these redrawing measures. And what you see, the percent of students who redrew the proportionate ratios in the invent condition was over 50%. So that's good because they had to get all 3 right. In the tell and practice, it was about 10%. So even though we had told them everything they need to know and we gave them the sheet, they never saw it. The reason is because when you tell them, they think they know everything they need to know, and they stop noticing the contrasts and the important features. This turns out to have significant implications for their abilities to learn. So what I'm showing you here is they later on had a problem around the spring constant, which is also a ratio. And I split the data into students who performed low versus high on their science achievement tests. And what you can see is if you're in the tell and practice condition, right, and that learned about the clowns by being told, your chances of solving the transfer problem around the trampoline are close to 0. If you're in the invent condition, right, you do much better. The important thing to notice here that I really want to draw and bring back to the question of AI, the low students in the invent condition did as well as the high students in the tell and practice. This is really important because what we're currently doing in AI and education is if a student doesn't get it, we tell them exactly the same thing, only slower and louder. Instead of trying to say, wait, maybe there's a better way to teach them so they'll learn it better. So now that we know about the power of contrasting cases, where can AI help? Well, right now there's a group at Stanford that's trying to automatically generate very effective contrasting cases. In this example, it's around character recognition for people who don't know how to read, but there are also examples of trying to figure out good contrasts for learning equations and other complex constructs. So in summary, a lot of the approaches that we have to instruction right now look good by the kinds of tests we give. The science of learning indicates that many of our current approaches to instruction are suboptimal for the outcomes we care about. For example, summarizing a chapter and then hearing a lecture, or being told the formula and then practicing. They both didn't work as well. The science of learning offers alternative approaches. And so I think AI in education should look to the science and not just our prior habits that we've inherited for how to teach. And I know everybody says, well, I did okay in that school system. You don't know how much better you could have done had you been taught correctly. So I think there's a lot of fresh possibilities for AI in education if you start human-centered with the nature of learning. So I hate to do this, but I wrote a book with my colleagues that lists 26 different things that we know from the science of learning. And it was written specifically for people who are going to create new technologies for learning so that they can get some fresh ideas instead of trying to continue and just make the past more efficient at achieving something we don't want. So thank you very much. I will end there. And it was my pleasure.
Thank you very much, Dan. Just to remind everyone, we have the Slido facility for asking questions. We will group them all and ask them at the end in the panel. So for now, we're going to move to our 1-minute lightning talks from Stanford students who are working in this area of educational technologies and AI.
In our research, we introduced StoryCoder, an app leveraging natural language processing to introduce computing concepts to children through storytelling games. Traditional computing education presents literacy challenges for our youngest learners. By leveraging the power of artificial intelligence, we've created a socially interactive voice agent that introduces children to 4 key computing concepts through storytelling games. StoryCoder consists of 6 voice-based user flows. By way of example, in the loops flow, we introduce the idea that a loop is something that happens over and over again. In this game, children can choose a music clip to play over and over in the background during each part of their story. Through an evaluation of our system with 22 children, we've demonstrated that we can use AI to integrate a conversational voice interface with creative activities to effectively introduce computing concepts to children in a manner that is accessible, approachable, and engaging.
Inspired by the figure drawing practice of creating multiple poses in rapid succession, Quick Pose is a version control system for artistic programming which enables artists to work across multiple concurrent ideas in a single artistic work. Built for the language processing, Quick Pose visualizes a project version history as a directed graph, allowing users to navigate across versions and create new branches with a single click. In contrast to existing version control solutions, Quick Pose foregrounds version control as an active part of the creative process, allowing artists to manage many branches and diverging ideas within a single project. To create a branch, users can double-click on any node to create a copy, or alternatively, as soon as users attempt to edit a previous branch, a copy will be created, automatically maintaining a linear edit history and making copies when appropriate. We hope Quick Pose will inspire version control tools for artistic programming, which recognize and center the divergent, exploratory, and unpredictable nature of the artistic process.
In our research, we introduced the Smart Primer, a smart tutor embedded in narratives with chatbot guidance. Traditional computer-based tutors consist of learning activities with limited interactivity, which tend to be unengaging. Leveraging advances in reinforcement learning and natural language processing, and drawing inspiration from Neil Stephens's novel, The Diamond Age, we built the Smart Primer learning system. It leverages compelling and personalized narratives, real-world activities, and adaptive feedbacks for tutoring chatbot. We ran a study with 72 grade 3 to 5 children that showed that narrative-based learning with a Wizard-of-Oz chatbot promoted student learning and engagement. Given these positive results, we replaced the Woz chatbot with an automated reinforcement learning-based chatbot and tested with 339 children. The IR chatbot promoted stronger engagement and learning than the control, especially for children with little prior knowledge. Today, students need novel, engaging, and effective methods to cultivate their passion for learning. Our research demonstrates the great educational potential of conversational AI tutoring systems.
I'd like to thank these and all of our students today for sharing this little taste of their work. And as I mentioned earlier, there are some resources and links on the conference webpage if you want to learn more. And I'm sure the students would love to get your questions and feedback. Very exciting. Next up, I'd like to welcome Chris Piech. Chris is an assistant professor of computer science and by courtesy of education, Here at Stanford, he uses machine learning to understand human learning, and he recently received an HAI grant called the Hoffman-Yee Grant for his research into AI tutors. Chris, if you'd like to share your screen and take it away.
Okay, what a pleasure to be here. Thanks so much, Russ, for introducing me. As mentioned, my name's Chris. I'm here to talk about how can we have AI superpower our wonderful teachers. This is work that's done by a whole bunch of people, and I'm just going to be celebrating it with you here today. So as mentioned, my name is Chris, and just a couple quick things about me. I do a whole bunch of research in computational education. That's my main focus of my job, but I also love teaching. At Stanford, I teach intro computer science, and I also teach probability for computer scientists. And you can imagine these are the sorts of things that a ton of people in the world would love to learn how to do. So I spend a lot of time thinking, how could I get the wonderful education that I can provide here at Stanford into the hands of as many people as possible? And today I invite you guys to think about the same problem with me. My question for you is, what can you do to scale up access to high quality education? It's one of the sticky, huge social problems that we face collectively. And what can we do to improve upon this great challenge? So quickly, what we're going to do today, I'd like to give you a bit of a vision for what cool AI could look like in the future. I want to talk about what AI can do to help teachers while grading, and then maybe how can AI help teachers become better versions of themselves. And at the very end, I'm going to give you guys a way to get involved. So gather around wherever you are in the world, and let's tell you a little bit of a story. This story starts about 1 year ago today. So a year ago today, as you guys know, a lot of the world started locking down because of COVID-19. And when this happened, I was about to teach Stanford's intro computer science class. And I thought to myself, with my co-teacher, Mehran Sahami, what can we do to make, to give to the world at this time when there's a lot of people who are hurting? So we thought about this. We thought, well, we teach this class. What can we do to give the wonderful education that we think we can give our students to more and more people? So we wondered, what can we do? And of course, people have mentioned MOOCs before. So we thought, maybe we can just put our class online, right? If you want to scale high quality education, can't you just take a Stanford class and put it online? Or we've built some cool AI stuff. Can we just make an AI tutor? And both of these things felt wrong. It felt like we really hadn't tapped into what made Stanford education so beautiful and wonderful. And actually, I'd like to tell you in my little story today, what is the secret sauce to Stanford's introduction to computer science, or intro to coding? You might already know this, but the secret sauce to Stanford's intro computer science is we build a huge amount of community by inviting a huge amount of our learners to come back and play the role of teachers. In fact, if you took the intro to CS class with me at Stanford, you would have one teacher for every 10 students, and all those teachers are recent graduates of the class. At Stanford, we've tapped into this incredible insight in learning. And the incredible insight in learning that I would like to share with you today is that the magnitude of the number of people in the world who would like to teach is roughly proportional to the magnitude of people who want to learn. Think about it yourself. When was the last time you learned something really exciting? Didn't you have this desire, like, could I pass on this knowledge to others? And it makes sense. When you teach, it's joyful. When you teach, you learn, you become you get to engage with sharing knowledge with other people in the world. So if teaching is such a fun thing that can make us so much better at our discipline, and a lot of people want to do it, what would it take to bring together the huge number of people who would like to be sharing knowledge and the huge number of people who would like to be learning? So in the time of coronavirus last year, we decided, let's try it. Let's do a massive experiment in education. Let's get thousands of people around the world to teach and get tens of thousands of people around the world to learn and put them all together in small groups. And it was a wonderful community service project. It worked so well. We had all these students who were learning and staying in the class and acquiring the ability to program. And these teachers were having a fantastic time as well. My thesis for you then is we don't need AI to replace teachers. What we really need is we need AI to make humans who want to teach more capable and who expand who is able to hold that role of teachers. So we can do this, but what we need is we need AI that doesn't replace teachers, but assists teachers. And today I'm going to talk about 2 quick points there. How can we have AI do the worst part of a teacher's job, which is giving the hard feedback on students' open-ended project? Well, it's the most time consuming. And the other one is, how can we make teachers become better versions of themselves? And if we can do these 2 things really well, then we can create an ecosystem where more people can be teachers and we can have more human-centered, scaled, more equitable education. At least that's my theory. So first of all, can we do some grading? The answer is surprisingly Maybe not, right? So for a while, I was trying to figure out how could I make the grading job easier? When I say grading, I actually mean feedback because you want to help people while they're learning. So a student does some work. Maybe they do some math. Maybe they write a short answer. Maybe they do some coding. Maybe they do a lot of coding. No matter what you're doing, you want a teacher to be able to say like, hey, I saw what you did. Here's this, it seems like you made this small mistake and here's how you can be better. Core part of education. Teachers are awesome at it. It takes them a ton of time, and AI is not. We had the best deep learning algorithms try and solve this problem, and it really quickly fell apart. Basically, I don't want to get into the details, but grading is a very hard mathematical problem for lots of deep reasons. One way of looking at this is we tried to grade code.org problems. Code.org were like 10-line code problems. So students would write 10 lines of code, and we would try and recreate human-level feedback on this code. We got the smartest people in the world working on the coolest deep learning algorithms. We got all the neural networks, and we couldn't do it even close to as well as humans. But we had this first insight, which is, what if we had our teachers, instead of just label stuff like they're pawns to the artificial intelligence neural network, what if we had the teachers teach the AI how to grade? And we worked in this new world of artificial intelligence, probabilistic programming languages, and we're able to come up with an algorithm that worked incredibly well. For the first time, we make some pretty good progress. We invented a whole bunch of AI along the way. It was a good time. We could say, hey, we've helped with grading. But you know what we couldn't do? We couldn't grade my midterm, and I really wanted to grade my midterm for my 106A class. Grading a midterm, giving feedback on midterm, it's hard. Student sees a problem, they write their answer, and a TA has to be able to say how the student is doing on a whole bunch of complicated categories. A little bit of suspense, because I want to show you some brand new results. Approach this with a really cool angle working with collaborators, Chelsea Finn and Mike Wu, and Chelsea Finn being the PI. We did this really cool project. Chelsea Finn works on meta learning. Basically, can AI become smart enough that if you give it a brand new task and do okay on those tasks? Well, I was talking to Chelsea, I was like, I've got brand new tasks all the time. So I can have AI that can look at some of my past exams and learn how to grade them, but I always have a new exam. Can we have AI that looks at those past exams and learn how to grade the new one? And the long story is short. Well, not if you just use the standard AI approaches. So we didn't use the standard AI approaches. We tried doing this really cool prototypical network. And if you don't know prototypical networks, maybe it's a cool thing to check out. It's on the current bleeding edge of artificial intelligence. We did try a whole bunch of things. We tried prototypical networks. We tried all these cool different tricks in AI. One of the secret sauces to doing good AI is to try a bunch of things. But at this point, we're getting really, really, really close to, can you grade my midterm, as well as the Stanford TAs who grade my midterm. So stay tuned, because this is one of the great challenges in supporting teachers. One of the places we're going to use this is Code in Place is coming back. It's a year since the pandemic started, and we wanted to do this big community service for the world again. So Code in Place is going to come back. We're going to have another 10,000 students, and this time we're going to be able to give feedback. Our 1,000 teachers don't have the time to give feedback. They have to focus on instruction, making great contrasting cases, but the AI is going to be doing the deep feedback work for them. The other thing I want to talk to you about, the last cool use of AI to superpower teachers in my little 10-minute talk, is how can we make teacher training better? It's a super difficult problem to become a better teacher. So I love teaching, and I'm always trying to become a better version of myself. But how can I? I teach my class, and then maybe some students said that was nice, but I don't really get deep feedback on teaching. So we're trying to build AI that can do this for you, AI that can augment the teacher training process. Whole bunch of cool things we're doing, and I'll give you a taste. One, we're making some AI-based teacher puzzles. So imagine you had an AI tutor, but instead of teaching you math, it was teaching you how to understand and teach others. Super meta. It's been a good time. And then, of course, when we do something like Code in Place, we have thousands of teachers teaching content, and we are learning how to look at their teaching and be like, we just watched you teach for 50 minutes. We can talk about how you respond to student questions. We can talk about how much you were speaking. We can talk about the language you use. We can even talk about small things like affect. And the AI can do automatically what would be impossible for me to do for my 1,000 teachers, which is give them feedback on their teaching. It's not a silver bullet, but this is a first step in a pretty cool problem. How can we have AI that can actually augment teachers becoming better versions of themselves?
1 minute.
So my question for you at the beginning of today was, what can you do to scale up access to high quality education? I just told you about 2 ways that we could help on one particular problem, which is how can we have AI to augment teachers? There's so many cool projects. There's so much to do in this wonderfully large and important space where there's new data and new problems. But there is one concrete thing you can do if you're interested. Code in Place is starting again. Come teach with us and you can be part of this wonderful conversation. So we're inviting people from all around the world to come learn how to become teachers. If you know how to code, come learn how to become a teacher. And in the process, you'll be contributing to this big present of community service we do for the world. What a pleasure. Thank you guys so much for your time and attention. I guess I'll be here to answer some more questions after the other wonderful talks.
Thank you so much, Chris. Incredibly exciting. Let's now turn to Amy Ogan. She's a professor of learning science at Carnegie Mellon University. Amy studies, designs, and builds educational technologies and has conducted field research on the deployment of this kind of technologies across 4 continents. Welcome, Amy. You can turn on your slides and take it away.
Thank you so much. What a pleasure to be here today in such wonderful company. Very excited to talk to everyone about these amazing ideas about how we are all working together to improve education for all of our learners around the world. And my talk today is going to be about pushing the boundaries of learning technologies, given that we are really in the midst of an education breakthrough globally. And maybe you've seen the statistics that look around the world at the reduction in out-of-school children. So more and more children are able to access schooling around the world, both primary education as well as secondary education. And this has been a major win to even get children into that system and enable them those educational opportunities. Of course, we're also in a learning crisis at the moment. Of course, you're all familiar with the fact that COVID-19 has forced billions of students to stay at home. And this has been a real serious issue for many learners around the world. But it's not the case that COVID is the only problem we have. So even before the pandemic, there were millions of school-aged children who were not able to learn basic primary level skills despite actually being in school. And this problem does not go away when we look at middle income countries or even high income countries, where 30% of students will learn only basic primary skills despite going through the entire schooling system. So there's been a lot of talk of technological determinism solutions, like just providing one-on-one computing devices and the potential that that has to increase educational opportunities. But we know that these have not sufficiently addressed the learning crisis, despite almost decades and billions of dollars being spent on just providing devices to learners. So a question is, does that mean we should give up and technology is not the solution? Well, there are some really encouraging results that show very positive outcomes from technology use, particularly when it's been enhanced with adaptive or AI-based assistance. So this is from a low and middle income country context, where this large meta-analysis of studies found that adaptive technology-assisted learning interventions had a greater impact than all kinds of other interventions, such as decreasing class size, providing school supplies, eliminating school fees, and others. So what we can learn from this is that learning technologies can actually support better educational equity with AI if we design them to. And the goal here is to meet each context where it's at. And so, as Russ mentioned, I do that by investigating a wide variety of educational contexts around the world. Here you see a number of the places where I've been doing my work. And what I've seen is that there are opportunities for AI, both in the end where there may be lower infrastructure available for AI to be situated and in place, but also fantastic opportunities in that higher infrastructure area as well. And so today I'm just going to share 2 of these projects with you to look at what we might do in a different set of cases, and in particular emphasizing in my work thinking about equity in learning opportunities within a context, which can be done across contexts around the world. So that first technology project that I'll describe here is called Allo Alphabet, and it's a phone-based literacy intervention that we've been deploying in Côte d'Ivoire. And what we're doing here is co-designing this technology with Ivorian linguists and sociologists. We're working with the Ministry of Education. We're actually been working with a local ed tech company in order to make this a sustainable intervention that can continue after the research concludes, and also with local community leaders to understand what's actually needed and how can we support children in this context. And what you see here is the deployment of a technology in which the AI itself is actually invisible. So this is a context in which the infrastructure may be low, so not all households have running water or electricity. However, the vast majority of households do have access to a basic phone. So they may not have the internet, but they can make calls and they can send and receive texts. And so that's the basis here of our literacy intervention that uses interactive voice response in order to deliver lessons and games and other activities to the students while they're at home and while they're learning in an out-of-school context. And as you can see here from this picture in which one of the family members is supporting the learning, as I mentioned, the AI is really invisible. So it's happening on the phone that the girl in the front left is holding. But what it's really doing is supporting this collective intermediation in which there's mutual support from a wide variety of community members. But what the AI is doing is bootstrapping that knowledge sharing. So it's interjecting actually a lot of the wonderful things that Dan was talking about in his talk. Contrasting cases, all sorts of inventive play activities around literacy that are being delivered by this phone, but then spreading out into the community where other adults or other learners in the environment are able to help structure that context of learning. They're able to provide explicit support, sometimes for the literacy, but sometimes just for how to use that mobile phone or how to modeling how to listen and respond while they're using the technology. And what we've found from this is that we're seeing a significant improvement in phonemic awareness and even larger improvement in letter reading from this technology. And one of the things that we've found is that students who report that they have consistent access to a parent at home are actually making even greater improvements. And this is demonstrating for us the value of incorporating the community and the rest of the learners' peers and support sources into the product, the AI product itself. Another interesting thing that we see here is the fact that this technology ends up being used when learners are not able to access schooling. So in this graph, you can see that the use of the technology was lowest during school holidays, when parents told us that the children should have a break and they shouldn't be working on their lessons. And then went higher when the period of normal schooling began again. However, in the middle of our study, there was a teacher strike for 2 months. And what you see here is that parents were using this in the home in order to provide their students with those opportunities, even when they may not have had them at school. From here, we're moving on to something that Chris was discussing, which is teacher professional development and supporting the teacher communities with AI. And at the same time, not neglecting some of the root causes of some of these educational opportunity gaps. We're here pairing this with a cash transfer intervention that enables children who are in such extreme poverty that they cannot make it to school to actually be involved in the schooling process. All right, so that was one study. Very quickly, I'll tell you about a project in this higher infrastructure space called Class Insight. Again, tying into what Chris was mentioning, but here we call it professional informatics for teachers, because even in a higher infrastructure space, there's still a need for designing for equity across learners. And so what you see here is a system of sensors that we're able to put into the classroom to collect a lot of really fantastic data about what's going on in the classroom environment without requiring everyone to be on a computer in order to collect that data. And so you can see here the privacy preserving features. We're collecting what's going on from the teacher's point of view, but also from the student's point of view in order to support teachers in making something visible that is typically invisible to them. And that is features of the classroom, like how often they're speaking, where they're moving in the classroom, how are their gaze patterns addressing the students in the back of the class, or those who may not have had an opportunity to have their voice heard during this classroom experience. So again, focus on educational opportunity and equity by changing the behaviors of the teachers and letting them have an active part in that process. So a large part of what we're doing here in this project is also around goal setting and providing teachers with agency to look at making changes that they desire to make. A cool new direction we're going here is to look at actually letting teachers experience this classroom in VR, so they can sit in the back of the classroom and really feel what it feels like to be participating, maybe from the point of view of a student who doesn't get that much attention. And so I'll just wrap up by saying that AI has enormous potential across all spaces of infrastructure and support. But one of the things that we focus on here is making sure that the context-sensitive design incorporates the physical infrastructure of the environment. So we need an understanding of what's already in place, and maybe or maybe not adding more. The human infrastructure, so making sure that we know that tech will never solve all of the problems. We're not replacing teachers, as Chris said. And so having that human in the loop and making sure we incorporate the human infrastructure is critical. And finally, knowing that equity will not be achieved organically, but it must be worked for. So things like 0 rating of educational interventions is a policy level decision that can actually help that AI reach the right set of people. And of course, there are thousands of people who have contributed to all of this work, and here's a small set of them.
Thank you so much, Amy. Very inspiring, and congratulations on the work. I'd like to invite our next speaker to join. And I'd also like to confess that I do not know how to pronounce your last name, Candace. So instead of faking it, I'm just going to ask you, how do I pronounce your last name?
Thille, as though it had no H in it.
Great. We had our staff desperately trying to figure it out, and we've actually found talks on YouTube where you've been introduced about 7 different ways. I'm sure you know that. So I'm extremely happy and now competent to introduce Candace Thille, the Director of Learning Science at Amazon. Candace's team works to scale and innovate workplace learning at Amazon. And before joining the world of big tech, she was a professor of education here at Stanford. Candace, welcome again. Please share your screen and take it away.
Okay, excellent. So I'm going to be talking specifically about the context of workplace learning. And I will say that the challenges and the opportunities in education are similar as the things that Dan, Chris, and Amy have raised. AI can be a Trojan horse to bring learning science rather than intuition and historical accident into the design of environments. Lots of people in the business context also want to teach, but don't know how to teach or share their expertise. And AI can help them become better teachers and help with tasks that are difficult, like giving effective feedback. And also improving their teaching process. There's huge variability in context, including access to tools and infrastructure, and the solutions have to fit that context, as Amy shared with us. And as we've all talked about, equity, AI can totally support equity in education, but learner voice and equity should be central to the design, and it has to be intentional in the design. Human learners in the workplace and in the world are extremely diverse. And they're not just diverse in dimensions of demographic diversity, but also in terms of their background knowledge, their skills, their goals, and the meanings that they make out of the learning experiences we present to them. So all of those challenges and opportunities, I would say, are pretty much the same between the education context in which I used to be all the time and the workplace context in which I am now. But there are also differences in the workplace context and additional opportunities from those differences. One of them, and I'll speak now to my current context, which is Amazon, is the rate of growth. Amazon hires about 350 people per day. And there are about 1.3 million people currently. And the learning experiences the infrastructure for learning design that I'm trying to design for Amazon have to support that diversity of learners. There's also an incredible rate of innovation and change. Old jobs go away, new jobs come in, and it's much better and much easier to reskill current employees than lose them. There's also an Amazon incredible internal talent movement. It's like a bunch of little startup cultures everywhere. So there's a lot of fluidity in people's roles and their jobs, and they are always looking for finding new projects that are a match for their current skill, but also have an opportunity for their growth and development. So all of these additional factors add additional opportunities and challenges to using AI effectively in learning environments. As my former colleague here at Stanford, Emma Brunskill, pointed out when I was talking about the context, she said, well, what you're working in is both a labor market and a university, because Amazon can essentially estimate the knowledge and skills that are going to be needed or are needed. And then they also have the capacity to support people to build those knowledge and skills. And then finally, to help people match their aspirations and their knowledge and skills with roles and jobs that need to be done. So there's a much tighter feedback loop between what skills need to be built and how to support people to build those skills. So let's talk a little bit about the technology that we're using to support these opportunities. As we've talked about, there's lots of powers of technology, and mostly in industry, people think about these three aspects of the technology: access and convenience. As was the case everywhere with COVID, everyone was working from home, but they still need to continue to learn and develop their capabilities. So with a computer, they can access that anytime, any place. There's also the capacity that you can do in technology, which is difficult to do in place-based classrooms, which is the simulation capability. You can use AR, VR, and other technologies to give people authentic experiences to learn from. And finally, the power of connection, that we're not, as Amy was pointing out, it's not just that the learners can be connected to the technology or connected to learning assets, but they can be connected to people, connected to other assets, connected throughout the world. And these three big powers are really where people are focusing, I would say currently, in workplace learning, using the technology to provide access, doing some interesting simulation stuff, although I would say not enough, and then using it to connect people. But as we know from this conference, this isn't the biggest power of this technology. The biggest power of this technology is what this conference is focused on. That when you're designing these learning experiences, you don't just use the technology to push them out. You use the technology to push it to an interface. Because in the interface, we can observe the learner interacting. And if you design the interface appropriately, you can observe the learner's interactions and make meaning out of them, model them to make estimates about the learner's state and other things, and then give good insights and feedback to the different human actors in the system. Now, this idea of instrumenting the learner experience and modeling those data, and then using those data, those inferences to give feedback, actionable feedback to the different human actors in the system, is not a new idea. This was the project that I started at Carnegie Mellon in 2002. This was the core of the idea there also. Use what we know about human learning to design the environments, and then use the power of collecting the data and making inferences to give feedback to augment the human actors in the system. The AI and the advances in AI have just made this model much more functional. So, I'll talk a little bit. I was going to talk a little bit about the sciences, but Dan did a great job on that. So I'm not going to spend a lot of time talking about that. The sciences involved in human learning are the neurosciences, cognitive science, which Dan went deeper into, and then also the social and psychological sciences. And one of the things that Dan didn't mention so much, he was mentioning how the sciences should be informing the learning environment. But the other thing this technology offers is the opportunity for things to go in the other direction. That these technologies allow us to essentially introduce constant experimentation into the learning experience. And the online environment has kind of the best of both worlds of traditional educational research. You can have an authentic learning environment where people are actually trying to learn, but you also can have as much control as you can have in a lab in terms of controlling the conditions. And the advantage of doing this kind of experimentation in a workplace like Amazon is when I was doing this kind of experimentation, when I was still at Stanford in MOOCs, I could collect a lot of data about the individual learners' interactions. And so I could make inferences about what was going on just from the period of time that I could collect their interactions. In a workplace, I have access not only to their actual interactions, but I also have access to all the other data about them as learners that a workplace has, and also about the context in which the learning is occurring. And in order to really build a robust science of learning, we need to really start to understand features about the learner, features about the thing being learned, and features about the context in which the learning is occurring, and how those different features interact in order to make good instructional differentiation decisions. So for example, we can both do really good research in this context because we have lots of learners that have a high degree of variability that we can know a lot about, working in a lot of different contexts, learning different things. So it's great from a research perspective. And then from a practice perspective, we also can look at sort of the standard learning development process and look at where in this process can we augment human practice most effectively using the technology and using AI. And so if you think about these sort of this is an oversimplification, but basically when you're developing a piece of learning technology to support learners to build knowledge and capability, you have to think about what's the skill model, what's the learning model, and then what are the activities you're going to design. And in what order do you give those activities? Like, do you give them contrasting cases first and then lecture next, or lecture first and practice next? So that, and then the learners actually engage with whatever those decisions are that you made, and they generate these traces, which we can then model to give insight back to the humans who make different decisions then about the design and the sequencing of the activities. Now, so we can insert AI into any of those different processes. One experiment that we did recently was having a PhD student from Stanford come up and do an internship with me at Amazon, where we did an experiment where we replaced the instructor idea of selecting and sequencing activities with a reinforcement learning agent. And we were able to quickly do this experiment in that we just sent an email out to employees at Amazon saying, do you want to take a class in linear algebra? And within a very short period of time, we had thousands of learners that we could then randomly assign to condition, either the instructor sequenced condition, the RL agent condition, or the open navigation condition. And so very quickly can do this kind of experimentation and see what we can learn from that. In fact, we did learn that the RL agent did do the best in terms of improving learning outcome and minimizing the number of activities that learners had to engage in order to achieve that outcome. But that didn't mean that we made the decision there to suddenly just do all teaching, all sequencing and selection of activity by an RL agent. But because there are other considerations like balancing learners' sense of autonomy and agency in managing their own learning against the efficiency of the decision-making that the reinforcement learning agent could make. So, but we can use this learning to say for some parts of the learning experience, under certain conditions, using an RL agent to select and sequence activities might be a better intervention than either the open navigation or an instructor sequenced learning experience. So back to this, the key here is to look at this as a whole system, both what the machines can do and the algorithms can do and what the humans can do. And to really think about, for all of the practices and decisions that each of the human actors have to make in the system in order to optimize learning, how can we, what parts of those decisions can we have the machine and the algorithms actually support? So I will take questions. Oh, and I do want to say, because I know as we're collecting all of these data about learners, that the other risk in a workplace setting is that learners are both employees and learners. So we create a safe space for learners to let them know that the data that we're collecting, the inferences that we're making are there to give them insight to support their learning, but not to make other decisions about them as employees.
Thank you so much for sharing your work, Candace, and especially for that last point, which I'm sure could be on people's minds. With that, I'd like to welcome back all the presenters and my co-host, James. This has been really interesting, especially for somebody like me who is paid to do teaching. It's kind of fascinating to hear. I'd like to welcome everybody back. Thank you for your talks. And James, I'd love to throw it to you for the first question.
These are really great, and everyone knows I have a lot of research interest in these areas. So I have questions for everyone, and questions that are coming in are great. So I have one for Amy that came in from our audience. They said, in the context of the Global South, are there insights from your Côte d'Ivoire IVR study that are applicable to learning at the post-secondary level in other resource-constrained contexts? That was one part of the question. And then the other part was, are there some idea from CMU's other AI studies that you think might also be applicable to digital learning at that level?
Absolutely. Great question. Actually, the local edtech company that we're working with there is working on developing a related version of this IVR technology for adult literacy. Côte d'Ivoire in particular has a very low percentage of adult literacy, and they see this as a tool that can actually transfer even more easily to that context. So particularly given that parents and adults are typically the ones who are the owners of the phones in those sorts of contexts where it might be particularly valuable, or there may only be one per family. Adult learning is something that is going to continue to be critical, as they may not have had those opportunities when they were children themselves. So there are differences, of course, between adult literacy and child literacy learning, but some of those same principles can absolutely apply. And I think that the physical infrastructure and human infrastructure lessons that we've learned will span across those areas.
Another audience question for Chris, but I'd be interested in everybody's thoughts here, is you use teacher grading to train and evaluate some machine grading algorithms, but of course, teacher grading might be biased and may miss meaningful things about the student, the interaction, the outcome. And of course, the risk would be the worry that AI would then replicate these limitations. So where are we in thinking about this for your work? And then I'd be interested in everybody else's thoughts about bias based on faulty training data.
Yeah, so it's a good question. And so just to say it back, if we can't be intelligent and thoughtful about bias from the beginning, we will recreate all the biases that existed before when we're doing grading. So there's a few things that have come up in this space. One of the projects that people have worked on is, can you try and teach the algorithm more than the human knows? So can you teach the algorithm, can you tell it in its optimization from first principle, your job is to learn one of these definitions of fairness for making your decisions. So when you're making your decisions, you need to know what fairness is, and you need to know how to do it better. So that's one approach that has been rather fruitful. And the student who did that has actually gone on to have a whole career in ethics and artificial intelligence. And then another approach has been to try and get more information that allows AI to make better decisions. So, for example, teachers only look at the final product. But now that we have AI that can understand work, we have the AI actually look at the whole process of how students arrived at that final product. And just by getting access to more high fidelity information, then you can make more useful feedback for students. I suppose both those approaches seem rather interesting to me. And then, of course, always looking at it. I think whenever you deploy any of this, like we're going to use it in Code in Place, and we have a whole team that is there to make sure that the benefits of this technology are going to hit all the learners in this class from around the world. So always be vigilant, and 2 good ideas, maybe.
I'm interested in the thoughts of others. These similar issues came up in the health section earlier this morning in terms of, especially as once you introduce these interventions, your training data, so to speak, will change and it'll be AI influenced. Has anybody thought about or worried about that?
So this is showing up in the non-AI world as well, right? Where there's always a concern that the SAT is not measuring what we actually care about, and it is unfair to those who have had much less opportunity. So this is a problem that's endemic to any sort of measurement enterprise.
I love that answer because it's exactly the same answer that we got in the health, where we said, look, there are so many other things that are creating injustice in the distribution of healthcare that although this may be one in the context, it might not be the biggest impact that we see. Thanks.
And yet, the one thing to be cautious about here is the scale. So something like an SAT is intended to be large scale, but AI has the potential to spread even further and to every learner. And so actually, James, we just heard a very interesting talk from your group from Denai Metaxa about algorithmic audits and making sure that we're doing regular evaluations, hygiene of our AI algorithms. And so one of the things that relies on is also, again, making sure that we get ever more representative data in order to feed into those audits and making sure we're not reproducing bias, which Russ might speak to your point of if we're continuing that loop, now we have access to the new data as learners are using systems and changing. And so we can make sure that we're ever improving.
Can I also just add one more thought? So I was really inspired, Amy and Candace, by your talks, because both of you spoke to AI that can help people who might not traditionally get access to what you'd imagine AI's powers being applied to. So I think there's a deep ethical issue in where we apply our AI. You can imagine one of the big problems we might run into is that we build AI that makes the rich get richer. So I don't know. I was really excited, Amy, to see about all the work that you can do to make maybe the people who, or maybe to use AI to make the gap in technology smaller, not wider.
Thank you.
Yeah, and also one of the things AI does really well is it reveals patterns. So we can, instead of just training a model and then implementing it, we could train a model and then look at what pattern does that model expose about how the system works, and then intervene on the implementation of that model to have it essentially mitigate the pattern that the standard process generates. Like you can introduce different weights or biases into the algorithm to mitigate the biases and weights that are in the data.
Yeah, I must say the training of all these models often exposes biases that are much more deeply embedded and not obvious.
Yes.
This has happened in healthcare. It's happened in, I'm sure, in education.
Absolutely.
Yeah, I think some of these questions about bias and policy also kind of leads into one question we got from a listener. And I'm going to give this to Dan since he's the dean. How should faculty and policymakers in resource-constrained countries and schools approach curriculum design in ways that, for example, they could incorporate things like your idea of contrasting cases, but with a focus on digital learning at the university level?
Okay, would you ask that one more time in just a short sentence?
How do people in resource constrained countries approach new curriculum design, like how to get things like contrasting cases as well as some of the AI technologies into their digital learning at the university level? Like how to even do it if they don't have a lot of money for it?
Right. So you saw, so this is complicated. There's a project going on right now that's making virtual field trips. And the goal is to make these field trips have shared adventures, the kinds of things that happen. And someone said to me, if you succeed, the consequence is the poor kids are going to take virtual field trips and the rich kids are going to take real field trips. Right. So it's not obvious to me that the rich get more technology is necessarily the final state of this. Mm-hmm. So the kinds of things I'm talking about are pretty refined as you make the AI. The kinds of things that you're worried about at scale are just big chunky questions of access. Can you get them to the table, right? And so these are big problems, and they're sort of made complicated because ed tech is a very tough place to make money, or it has been, right? And so if you're a teacher, you go to the app store and you just choose a technology and you expect it to be free. Well, if it's free, then there's nobody pouring money in to make it better, right? And ensure that it has quality control. So this is kind of an ongoing problem, and I don't know that AI is the solution to this, but in general, if you try and do these things without a financial incentive, you run into lots of trouble. But if you put in a financial incentive, it's going to make it tough for the poor countries to be able to get it. But in any event, the simplest solution is cell phones have opened the gateway for a lot of special stuff that you could do at low cost, and AI is just a great way to deliver it.
I also, just to add onto that, think that the COVID pandemic has really opened up the landscape here, where many universities in low and middle income countries also had to serve an enormous amount of learners, oftentimes online. And so Dan spoke about the financial models. Right now, the MasterCard Foundation, for instance, is working with a large number of really excellent African universities to make sure that their transition to online materials is leading to very high quality experiences that are reaching even more learners than they would have expected to previously, those in refugee camps, those who are displaced. And so I think this has actually, in some cases, really opened up everyone's eyes and funding models also for this to happen in many more places around the globe.
Yeah, and the only concern about that is we open it up and make it more available to people around the globe to make sure that the science gets inserted, as opposed to people thinking, oh, I know how to teach, I'll just make a MOOC and make that available to everybody.
So it's interesting. I read a report that Uruguay did not, the learning rate of the students didn't flatline. Like in the US, during the spring and summer, reading scores just flatlined. And now they're rebounding. Uruguay, that didn't happen. And the best thinking on that is they had already invested in digital technologies for learning, that they were committed to this before COVID. So they were in a position to take advantage of it. So if groups now become prospective and try and plan, I think there could be a lot of good things that would happen.
I guess a fear I have is that COVID, the rush to online for COVID, then people think their prior knowledge now is online is not as good as in person. And so what we need to do to get education back again is get everybody back in person doing what we did before COVID. It's like, let's get back to normal, instead of what I think a lot of us were hoping is that this creates an opportunity to change the way we're doing teaching and learning.
That's very interesting because in the healthcare discussion, patients love not going to the doctor unless they absolutely have to. And doctors actually don't mind talking to patients over Zoom as long as they don't need to have the patient in front of them. And so it's a little bit of a different dynamic in healthcare. And I think I take your point that it would be nice if there was a little bit of that going on here. Partly it's who holds the decision reins. In the case of children, what the children want might not be the thing that drives the day.
Or even in the case of higher education students or workplace learners that are adults, it also what they want or what they might think is the best way to learn may not actually be what supports their learning the best. Like I think if you took any of Dan's studies and you surveyed the learners before the study and asked them which do you think is going to be most effective, everyone would guess wrong.
Maybe I'd jump here and say, I think on some level, though, learning's such a deep social activity, right? Like we're talking about something that's core to just who we are as human beings, passing on. I have a new daughter, and I feel like one of my main jobs is to teach her, right? And just this process of teaching her, it's one of the things that makes me human. And I think one of the things that seems to have happened in the online learning world is it somehow became less social. I don't think there's a future of education where we remove that social. And sometimes I've seen education AI projects that's tried to make a future of education that is somehow not social, right? You're just going to go online and learn from your AI tutor. I think if we don't figure out that social human part, people won't want to do it. It doesn't matter where in the world you are.
So kind of related to this discussion, this has been a really, I don't want to cut this off because what we were just saying is really, really fascinating. But Candace, one of the questions came from the audience about any lessons that you learned or surprises moving from an explicitly educational environment at Stanford with undergraduates and graduate students to an organization like Amazon where learning was important, but it wasn't the explicit number one goal. Any surprises or differences, or are they remarkably similar?
They are remarkably similar. I guess the thing that I was surprised about was part of why I thought Amazon would be a great place to make this transition was because of that core capability at Amazon, which is you take core business processes and you instrument them to collect evidence to give insights to the human actors in the system so they can make dynamic real-time decisions that continuously optimize the system to innovate for customers. That's kind of like the lifeblood of Amazon. So I sort of expected when I came there so I came in and said, okay, we're going to try and accelerate learning. What's the data we have now about how effective all of these strategies are that you're using to support learning? How effective are they now? So that I can see what our baseline is. And everyone looked at me like I had 5 heads. And I think that is because people have a special place in their brains when they think about teaching and learning that's separate from everything else in their life. Everyone thinks, I know how, I've been a teacher, I've been a learner, I know how it works. So this idea that you might need to collect evidence about what works and doesn't work, and that things might work differently in different contexts for different people was kind of is still an idea that I think is challenging for a lot of people, and a lot of people in education too. What's been workable is to give that analogy, to say it's a core business. Developing the knowledge and capability of the employees is a core business process. And so we should instrument it and understand what works for whom, under what conditions, when, learning what kinds of things, so that we can give those insights to the different human actors in that system to make that process more and more and more effective. And ground it in the science of what is already known about human learning. Start from there. Don't start from how I've always taught or how I've always learned. But don't just start from intuition or history.
You touched upon this in your talk, but how difficult is it to really have the trust of the employees that these instrumentations of their learning performance won't bleed into the instrumentation of their job performance?
Yeah, so right now the learning environments that we're building are in a specific location, and we tell the learner right up front what will and will not happen with their data when they engage with that. And the basic message is that this environment, what's required of you is to build the knowledge and capability. It's not required of you to take this course. There's not a mandatory course that you have to take the course. So you're not just trying to complete taking the course. Your goal is to build the knowledge and capability you need to build. And lucky for you, these courses are designed to support you to do that. And we're going to be collecting these data and making inferences about your current state relative to your desired state so that we can tell you how you're doing and also make suggestions about places that you could go, things you could do that would help move you to your desired state faster. Those data and those inferences are just for you.
Mm-hmm.
That is wonderful that Amazon is able to promise that, because this is one of the biggest challenges that we've seen in the work where we're looking at professional informatics, is absolutely the concern that this will be evaluative and oftentimes distrust of the system in which the employee finds themselves, in my case, teachers.
Right. Yes.
Chris, I don't know if you've seen this as well, but maybe your teachers, the participants are more informal, whereas mine are getting paid, and that is their job.
I think there's a question about a little more of the detail on that, Chris. So one of our folks in the audience said that, what kind of feedback do you give on code? I think they had a misperception that you might just say, oh, it works or not. And so I think saying, for example, because I think this is really what's been innovative, is what kind of feedback could you give? But then the follow-up to that I think was really more important from this questioner was, how might you achieve comparable insights into teaching humanities or other less structured domains?
So, okay, I love the question. I'll just jump into the first one. The sorts of feedback we're looking for are hopefully deep ones that could help you grow. So we don't want to say your program doesn't work. A lot of programs that don't work, unit tests can tell you it doesn't work. That's not what's surprising, and that's not what's hard. What's hard is to find out, like, what is the concept you're missing? So the sorts of feedback we're looking at are, you have an off by one error, and here's what an off by one error means. That's the sort of feedback that we want our AI to give. And for the humanities, we think of ourselves as on a spectrum of complexity of tasks. And code is somewhere in the middle, right? It's certainly easier than poem, giving feedback to somebody writing a poem, and certainly harder than giving feedback to somebody just writing a simple math equation. Though interestingly, the statistical properties of code follow the statistical properties of natural language pretty closely. It's just like, you can think of it as easy English. Giving feedback on English is brutally difficult. Code is like an easy version of English. It's like, has a lot of properties of language. It's just a smaller you can think of it as a smaller set of tokens from which you're generating your language. And we're making progress towards that. But I would feel very skeptical if somebody said, I have an AI algorithm giving feedback on an essay, just basically because I'm deeply and painfully aware of how poorly AI can really, to its core, understand language and English. So an important goal and project, but something that we need to work towards and be cautious about how good our results are at the moment.
James, I have a question for you, since you asked the question. It's not obvious to me what is the quality of the humanities that's going to make it difficult. Is it, there's no true answer, whereas programming there is? Or is it that the way humanities are taught, there's less interactivity, so there's less data to be able to make decisions? Do you have a sense of, you may have heard this question before.
Yeah, so I mean, I would say it's not just the humanities. I would say in lots of domains where the task doesn't have such formal structure. I mean, programming is almost underlying it like math. So there is this structure that you're able to take advantage of to be able to see what's wrong and get that insight. And a lot of other problems maybe don't have such a structure to take advantage of for the machine learning and for deducing these. And so the question is, how might you find some structure that would be useful in that way, I think is one of the things. But I think it's an open question for Chris, and I want to keep pushing him on it because I think that's the wave of the future, is how we get to places like that.
So I can give you an unsatisfying answer that's in the right direction, which is, we tried to have some AI grade in a context where students could make any program they wanted. So the idea was, be creative in your program. It's not do what we say, but just do something that celebrates what you've learned. And obviously this was really hard for a AI. But then, whenever you take a problem, you dig deeper into it, there's something interesting to be done. So now we have our AI playing with every single student's work and to try and figure out, while I'm playing with it, can I figure out which ones are somehow sparking my artificial intelligence joy? It's not getting towards deep answers in humanities, but maybe it's a step in the right direction.
I believe that AI intelligence joy needs to be tweeted immediately by somebody. So please do that, someone. So I love this question from the audience because we're getting to the end of the day. Are we in jeopardy of AI really replacing? This is about augmentation, this conference. Is the replacement of teachers a present danger and present worry that you as professionals are worrying about? Or is it just something that people talk about, but you don't see it anywhere near? Because people in the question, they were referring to governments that might be tempted to cut their education budgets, et cetera, et cetera. So how much of a danger is this? And what kind of attention should we be paying to it?
So there are crazy people all over the place who are going to propose all sorts of stuff. There's a school that I kind of like what they're trying to do. And what they've decided is for 3 hours a day, the kids only learn sort of very rudimentary basic skills on the computer, the kinds of things that are repetitive and so forth. And then for the other 4 hours, they just do enrichment projects and the teachers take charge of that. And so they've sort of decided, well, the AI is going to be good at this thing that we really don't need humans for, but this other stuff we really need the humans for. And so we're going to put them there. So that's an interesting sort of hybrid solution. But it's just maybe you get an AI robot that can handle a classroom of, first graders. I'd be really impressed.
I do think this is a really important question, though. So I showed a graph in my talk that showed that our learners were using our system equally during a teacher strike as they were during a normal schooling period, compared to the holiday where the parents thought they should have off. And for the parents, this was critical. Their children had no opportunity to be in school to learn for 2 months of the school year. And that's an enormous lost opportunity. For the teachers, this could be viewed in a much more negative light that, the teachers' needs were not being met. Their demands for higher pay or for a better status were being supplanted by parents' ability to find alternatives. And so I don't think there is an easy answer to this, even though I think it is not the case that my system or any system is replacing teachers and in any near future situation. However, it is not one that can be dismissed easily when these systems are so complex.
Amy, out of curiosity, did the teachers and parents have that conversation in the context of your study?
Well, so this is a very, a context where you have to understand all the rest of the context. So in this location and in several others that are like it, parents also often spend what little extra money they have to engage tutors or other learning supports after school when they believe that maybe the children aren't getting everything they need in the school day. But then also that starts a market for teachers themselves to be paid as tutors after school to supplement what was happening in the school day. And so that in this case, the teachers did not actually mind, and they told the parents, we'll work with your children with the technology, and we'll do it outside of school. So this particular instance didn't cause any conflicts. But as you can see, it's a larger system that's broken. And so introducing the technology has interesting ripple effects on how that works.
Can I throw in a hot take? I don't know if we have time for this, but AI replacing labor has been something that's been on all of our minds, right? Can you imagine a future in 200 years when there's a lot less work for us humans to be doing because AI is really good at it? The one thing that we're going to need is human teachers, I think. In 100 years, we're going to need to be inspiring each other and teaching each other what it means to be human. I think it's actually the one thing that's going to need more humans as we get into a world where AI can do more laborious tasks. It's the thing that scales with number of people the best. So I can imagine a future where, we're going to need maybe 1 in every 10 person is engaging in teaching in some way. I put all my money on that one. I don't put any money on.
Chris, I'd like to challenge you just a little bit.
Okay,
that
please.
I'm not sure teaching is the only thing that can't be replaced. I think
Yeah.
parents are
Sorry.
still pretty important. But
Thank you.
but I liked your point a lot.
Well, and it also questions whether teaching will be a paid profession or whether it itself will transition. So there are lots of models being proposed such that anyone can teach, as you know, and they may just need to be supported by some technology. And so I think that it's interesting that you bring up the labor question, because certainly teaching is fundamental to the human experience, but whether or not that continues as within the labor force as a paid profession, I think is a different question entirely.
I think this this replacement question is one of the important themes of HAI and how we're focused on how do we augment rather than replace. But this is going to happen in many areas, and it's really important. So, one of the people out there, for Candace especially, said, how will AI for education be prepared in time to address worker displacement and help retrain the workforce when all that displacement is in itself maybe due to AI? So do folks want to comment?
Yeah, exactly. So when I was at Stanford and Carnegie Mellon before, and the Chronicle of Higher Education would write about my work, they'd always put a big picture and say, and the headline would be something like, "She's trying to replace us with computers." And that would be the lead. And what I used to say when people would lobby that at me is, well, frankly, any faculty member who can be replaced by a computer should be. I stopped saying that in faculty context because it didn't get the response I was looking for. What I was trying to say was, if you're truly being a faculty member or a teacher, the things that you can do are so much more robust and important in the relationship aspect and the supporting the learners aspect than any computer system that we can currently build. That if that's all you're doing, then you're not actually being what I would think of as a faculty member or a teacher. The other side of that is, at least when I was a faculty member, not so much at Stanford, but I worked a lot with community college faculty and faculty at other institutions not as privileged as Stanford. And I looked at the task that faculty members were being given to do, which was educate hundreds or thousands of learners with huge variability in their background knowledge, in their skills, in their goals. And the classes are getting bigger and bigger and bigger and bigger, and the time is getting shorter and shorter and shorter, and the amount of information, the number of skills that people have to learn is getting bigger and bigger and bigger, and it's not a doable task. And it's not fair to be asking teachers and faculty to address that new context without giving them better tools. And that's what I think about this AI augmented teaching to be, is giving teachers better tools so they can do their profession better in this very changed context where the demands on their expertise are much greater than they were in the past. So do I think that these computers will replace teachers? No, but I think they will allow many, 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 many more people to have access to a high quality education, and allow many, many, many more teachers to be able to focus on the stuff that they really love to do and can do best.
How about the workforce beyond the teachers, though? How about the delivery drivers, the warehouse workers at Amazon and other fields? I mean, is that where the action should be to help those people?
Oh, absolutely. And at Amazon, that is a lot of where the action is. As I said, I'm building systems that are supporting all Amazon employees. That isn't just the most advanced machine learning scientist at Amazon, but also people who are in the fulfillment center, not because they chose that as their career, but because that is a good job that they could get. But that's not necessarily what they want to spend the rest of their life doing. So can we provide opportunities both to support them to reskill or upskill to get roles outside of Amazon, but also have really clear pathways within Amazon. So if you're starting, and so if I can have a good bead on what your current knowledge and capabilities are, and I also know for all of the different roles at Amazon what knowledge and capabilities are required, then when you're thinking I might want to do something different, or when your role is being eliminated because of automation, then you can query, what are some options for me? And the system can help suggest things that might be close to what you seem to be able to do now, that require some additional skill building and capability development, and then recommend assets or opportunities that will help you build those skills, and then help support you and tracking against how am I doing about building those skills, but also support you to make changing your decision. If you start that path and you think, oh, this isn't what I really want to do, this kind of sucks. What are now, but I now have new skills. What are some new opportunities that are available to me? So that's what I mean about using the AI to support the different human actors to make good decisions about their own learning. And that includes learners making good decisions about, what is my current skill set? What's my desired skill set, and what might be some things that I could do to help me move from my current skill set to my desired skill set. But really focusing on human autonomy in that decision making, supported by the AI.
So Russ,
Yes.
I know you're a futurist. I don't know if you can look backwards as well, but do you think when the book showed up, people were asking, will this displace teachers?
So I bet you, I don't know, but I bet there were people who were threatened by the introduction of the printing press and who said, this is not good, and who's going to retrain me?
Or that the TV was going to.
Maybe the monks, right? The monks are the ones who were the big, the monks took the big hit. Actually, okay, so that actually leads me into my question for Dan. Thank you, Dan, which is a little bit on the economics. You said during your talk that people often expect educational technologies to be free. And, we have to consider the public education system in the United States, which is not known as an incredibly well endowed, or I don't think of it that way. But so is this going to be deployable in large, and this is a question for all of you, are these technologies going to be realistically available to public institutions versus mostly available to well-funded private institutions?
Why?
I wanted to end with an easy one.
Yeah. I'm sure there are people who are going to try and make lots of money and corner the market. At the same time, if you're a teacher and you have a computer and a projector, you use YouTube. Everybody uses YouTube, and it doesn't cost the teacher anything, right? And so that's a different model, that the tools themselves are so usable that they'll try and find other ways to finance them, but get them in everybody's hands.
I have a question that's come off from a few people, which said, they noticed that AR and VR haven't come up in any of this conversation. And they want to know, what are the best places for those technologies in the future of education? I know Dan's doing some of those things right now, so maybe you could say a little bit.
Yeah, well, I think we're just figuring it out. But a lot of good learning is experiential, right? And so you want to, which is hard to do in classrooms, right? It's hard to have sort of experiential things. And so AR and VR are going to be very good for that. Right now, people look at VR largely around training, things that have a large perceptual component or a social component. But I think you can begin to open it up. AR is really interesting. I don't know where that's going to go. The idea that I can walk around and suddenly see a prize hidden behind a rock that has a question for me to memorize a vocabulary word or something. But yeah, I think it's the experiential quality. And so there's another thing that came is just computer simulations, this ability to engage with a simulated MRI machine, right, as a way to learn about neuroimaging. This is fundamentally new. You couldn't do that 20 years ago. The computer wasn't capable. Where will AI slip into that? It's interesting because they produce a spectacular amount of data, but because they're experiential, the degrees of freedom for what people can do in there is very broad. So I think it's a next space to move. Is the technology? Now it's in the hands of everybody. I just played one of those games, and it was like I took the mask off, and I was like the commercial where I went, "Whoa," And so there must be ways to use this really effectively for learning things, maybe not algebra, maybe not programming, but maybe other things that really depend on experiential component.
So I mentioned it very briefly in one of the directions we are going with teacher support is actually enabling teachers to, sit in the back of their room and feel what it's like to have that experience of being the student who never gets called on or who doesn't participate. And I think that Dan's right. That's the real value here is perspective taking experiences. And that's where VR is going to solve a real need, where in many other cases, it's not something we need in order to have the best quality learning of that topic.
Yeah, that's a really great one, because I think we saw a talk in our HCI seminar a couple of weeks ago from one of your junior colleagues who really showed some great stuff on that from his PhD dissertation. So it was really nice to see.
Yeah.
I mean, it's also a great opportunity for doing contrasting cases, because since you can manipulate the reality, then you could introduce the significant differences that you want people to notice, but not have it be so obvious. It's like looking at the pictures of scissors. It would definitely support people to get better at noticing the deep structure differences in the context that you're trying to get them to understand.
Learning to recognize poison oak. I prefer to do that in VR.
Yeah.
Yeah, or your surgeon's first surgery.
Yeah.
There has to be a first, and you don't really want to be the first.
But it is, James, it really is an interesting problem or opportunity. Here's this thing that just didn't exist before. How are you going to use it? So I'm collaborating with a cardiologist who's made it so that you're dealing in virtual reality, immersive, with a heart, and you can go inside the heart. Like there was this old movie, Voyage, I forget.
Oh,
you go
yeah.
inside and you can sort of see, there's a perforation, and that's the way the blood flows. And it's unbelievable. And we're busy saying, well, this has to be good for something, but we can't figure it out.
Actually, with that, also a tweetable moment. I think we should bring the panel to a close. It's been a fantastic discussion. I want to thank you all for your contributions and your talks and the really fascinating discussion that's gone on. I think we'll move to the closing out with James and me. So I will thank our panelists and excuse our panelists. And James, it's been quite a day, and I don't know if you feel like summarizing it or not. I did see themes, but I think that probably our audience and our colleagues listening in heard the same themes. But would you like to say anything as we end up today?
Yeah, I thought there were some things, both common themes as well as interesting surprises that came out. So one that I thought was quite interesting was this thought about how AI systems are going to need to deal with training data. Eventually, that's going to come from AI systems that are deployed in the field, and how a lot of the AI designers are maybe not yet aware of some of the issues that's going to raise, in addition to the usual problems of just trying to deploy real systems. So I thought that was an important learning that we had some really good comments of, especially from the health panel. And another thing that I think we heard both in the art and the health and here in the education is that for AI to successfully augment people's lives and their work or play, that the practitioners of these fields have to be part of the conversation. So we need to do real, what I would call human-centered design or human-centered AI design, and involve these folks in the design from the start if we're going to truly be able to get to augmentation. And we saw that very clearly in the music domain there, where we had Carol working with, Grammy-winning violinists as well as these other experts in that field to try to come up with their ideas. So I thought those were really important things that came up multiple times that I thought were really interesting.
Yes, and I thought that I was also very happy to see the importance of diversity, fairness, and justice, which almost go without saying, but where in many parts of our society we have not delivered. And so to have those be an integral part of all three of these discussions is not the answer, but it's definitely a good start and in the right direction. Your closing thoughts and comments.
I think there were some of those bigger themes that were underlying a lot of these that I think we as a field need to really watch out for. So things like privacy of the data came up in a lot of places. The agency, if we're talking about this being augmentation, is there agency with the human? Though we even saw some cases that Eric Horvitz talked about in medicine where maybe sometimes the agency is on the machine. And so trying to figure out, when is it human in the loop versus machine in the loop, and what does that mean? I thought these are really interesting questions that, again, we don't really know the right answers to. And so they're really great research questions for the junior researchers out there, the graduate students, the undergrads who are jumping in these fields. These are great questions for folks to start thinking about PhD dissertation-like work. And there's going to be a lot of good work because I think we have a lot of great questions. So I want to wrap with that. I think I want to say I sincerely hope that our audience enjoyed their time today, and we want to hear how we can improve. So those who registered will receive a survey in the next day or two asking you what you liked, what you don't like, how our next conference can be better and exceed your expectations. And I think it's going to be really good. We're going to be focused a lot on the policy and other impacts of AI and how we might rein it in. And they're going to really question some radical ideas on that. And I think it's going to be fun. Also, if you want to learn more about HAI and our work, you can rewatch this conference video because I know some of you had to pop out and do your job or get lunch or whatever. But you can also attend our weekly seminars. They're online, so you can get there. You can see all this stuff on our website at hai.stanford.edu.
I also want to give a big thank you to our dedicated HAI team who made this conference possible. Deep Ganguly and John Robichaux, our directors of research and education, were watching the questions and feeding them to us. Our communications team, Stacy Pena and Shauna Lynch, were critical at all stages of planning. Thanks to Stanford Video and Gordon Gurley in particular, who produced the live stream. And a special thanks to the queen of media at HAI, Celia Clark, our events manager, who shepherded us beautifully and gently through this event from start to finish. Please mark your calendars for the fall conference, Governing AI, 4 Radical Proposals for a Better Society. That will take place November 9 and 10, 2021. Thank you, and see you next time.
Thank you.